Hello everybody, I'm pretty excited about this video because as some of you might remember, last year I made a couple videos questioning whether or not the curve was going to flatten out, we were going to reach the plateau of a sigmoid curve, or if the singularity was even going to happen, and I will come back and unequivocally say the curve is still getting steeper. Now, how long will it last? I'm not really going to address that in this video, but right now, at least, the curve is still getting steeper and acceleration is still accelerating. Also, if you hear anything in the background, it's my dogs. They're chewing on their bones and stuff. So I apologize. Anyways, okay, so you might see graphs like this pop up on Reddit or Twitter or LinkedIn or whatever. And there's plenty out there. I figured I just needed to show you one. But what you're seeing here is not just a geometric level of improvement of these benchmarks. And it's not just one benchmark. You see that there are 5 benchmarks covered in this graph, and they're also just kind of all popping off right in the last couple months. Now, this is what I mean by the acceleration is still accelerating. Another way of thinking about this is that we have not squeezed all the juice that there is out of squeeze out of this current paradigm. Now, this current paradigm seems like it will take us all the way, not just through AGI, but maybe all the way to superintelligence. And to me, this is not particularly surprising because when I first got into neural networks back in 2009, which was a lifetime ago, I made the simple reasoning. I was like, well, nature and evolution and biology were able to solve intelligence with neural networks, so therefore there should be no difference between that and artificial neural networks. Now, obviously, that is a vast oversimplification, but that was my logic, and that logic seems to be holding. I've seen some people try and make noises, like I think Jeffrey Hinton was talking about, like, oh, the neurosymbolic people never really figured it out. But I don't really think that that's a legitimate argument because LLMs are neurological and symbolic. Like this is just what neurosymbolic AI looks like. It looks like a large language model that also happens to be a transformer deep learning, deep neural network. So anyways, it's mostly semantics at this point. Moving on. So the acceleration is still accelerating. Here, let me activate cursor real quick. I apologize. There we go. All right, now you can see where the mouse is. So number one, data wall. We were like, as you've probably seen some tweets from like Andrei Karpathy and Ilya Sutskever and those kinds of guys, or the presentations that they've done, where basically like we have one internet, right? And we've already consumed pretty much all of that one internet. But the thing is that GIGO still counts, and GIGO means garbage in, garbage out. Most of the internet is garbage. What we've gotten to at this point, though, is models that are smart enough to generate synthetic data that basically says, okay, here's a whole bunch of mess and noise. Let's distill that into actually useful information. So you might have heard last year, rumor had it that really what OpenAI was spending all that time doing was synthesizing new data. And that's actually where the huge heavy lift came from with like in terms of cost, is that they had to spend a whole lot of time saying, all right, we have this whole internet thing, but let's just spend a whole bunch of tokens on inference to actually synthesize new, better compressed data. So what they did, this is my personal inference. What they did was they said, okay, we've got this mountain of data, most of it is garbage, but let's improve the signal to noise ratio by resynthesizing this data and creating a whole new entirely synthetic data set to train on. Or at least partially. They probably still train it on the internet as well, but you probably have a larger section that is just like, okay, this is actual textbooks of how the world works. Another thing is that these reasoning models seem to be operating very much outside of their training distribution, meaning that by having learned and generalized first principles reasoning, they're able to address completely, truly novel problems. Now, a lot of people aren't talking about this yet, and it could be because maybe I'm just making stuff up, but in the past, more often than not, when I've made these kinds of inferences, I've been correct. So I would not be surprised if we start seeing benchmarks or papers coming out saying like, hey, these models are actually generalizing from first principles. And now that I think about it in hindsight, a lot of people call this emergence. So it's like, oh, reasoning just emerged. But really, even if you go back to like GPT-2, there is some level of reasoning. It's just you don't really know what to look for until after the fact. And then when you go back, you're like, oh, it was there all along. And the reason I'm bringing this up is because I have come to believe now that I'm learning to look at models and like what a model does, when it is reasoning from first principles and generalizing beyond its training distribution. Sonnet 3.5 does it all the time. Some of the Claude styles that I've made allow it to create really specific terminology, and it'll invent new terminology. It's like, okay, based on this school of thought and this school of thought, this is the term that makes the most sense, and it can articulate and define entirely new terms. Now, sometimes it makes stuff up. It hallucinates. My wife pointed that out to me. She's like, it hallucinated all that. I was like, but what's the difference between creativity and hallucination? Anyways, so what we're talking about here is a combination of distillation and a few other things. But also this research is recursive. It's getting into a recursive loop, and I'll talk about that more later in the video. There we go. Okay. Now, one thing to keep in mind, though, the reason that I think that the acceleration is still accelerating is because at a fundamental level, it's all just math. All the data that goes into these things, it's just math. All the tokens, all the attention windows, all the loss functions, it's all just math. And once you have a closed system that has enough information inside of it, you can keep playing in that sandbox forever. So, if you go back to the era of GPT-2, GPT-3, the sandbox was really small because first, the cognitive engine, the GPT, was itself not particularly smart, but now the GPTs are really smart, and you've also got a whole bunch of toys in this sandbox that they can keep playing with forever. And DeepSeek R1 proves this because it primarily learned through self-play. At least that's my understanding. I haven't read the full paper yet, but I've watched a lot of other people talk about it and been following the news very closely. So at a certain point, once you have a closed system that has enough information inside of it, you can get to critical mass. And that's actually, so critical mass is actually what happens in a nuclear reaction where it's like, okay, you have enough neutrons breaking up other nuclei that's firing into more neutrons and breaking up more nuclei. And I kind of think that that's where we're at. I think that we just hit, particularly with the release of O1 and this generation of reasoning models, I think that we kind of just hit critical mass in terms of artificial intelligence, meaning that no outside inputs are really necessary anymore. Now, certainly these models will always benefit from having more high quality data, which will trickle in. But at the same time, they can reason from first principles and generate unlimited data, which means they can, and also the algorithms are all open source. So that means literally the only constraint is compute. And as some people will point out, a downstream consequence of that is energy, because compute doesn't work without energy. But at the same time, the compute is getting more efficient. So maybe energy actually isn't that big of a constraint that we thought it would be. Time will tell. Okay, so another thing is, speaking of first principles reasoning, when you look at the actual energy being used in, for instance, the human brain, which, we don't even know how many calculations per second the human brain does, because every time we build a new supercomputer, we think, this is close to the human brain, but then it's not. And when I say it's not close, I don't mean it's like 20% off. I mean it's orders of magnitude off. And the human brain only uses about 20 watts of heat or energy. Now, the rest of the human body uses about 80 to 100 watts of energy, but still, running a light bulb is how much these little, 3-pound cholesterol computers require. So my point here, though, is that we are nowhere near the thermodynamic and physical limits of how much computation can be squeezed out of these things. And there's also, so this kind of goes both ways. So there's a lower bound and an upper bound. So the lower bound is going to be Landauer's limit. So basically, that's the minimum amount of energy required to do a computation. But then there's other things. So Gödel's incompleteness theorem, Turing's halting problem, quantum uncertainty, and irreducible complexity. These basically say there probably is an upper bound of intelligence or an upper bound of useful intelligence, because just because you can construct a more complicated, sophisticated abstraction doesn't mean that abstraction is going to have utility in the real world, meaning it might not help you make more accurate predictions. So there's probably going to be a point of diminishing returns, which is what I've been talking about a lot lately, because now it's not a matter of can we get to that, it's where is that level of diminishing returns. And I don't really know yet. I haven't really seen any evidence that we're at the top, but mathematically we can predict that there is a maximum useful intelligence or a ceiling of practical intelligence. Now, at that point, though, you can still work on optimizing, finding heuristics to make you go faster, because eventually, if everyone, think of it this way, in a world where everyone has superintelligence, the person that wins is the one with the superintelligence that is faster and more efficient, because then they can run more of them in parallel. So that's where the race dynamics are taking us now. Now, I have spoken to insiders at all kinds of tech companies, from NVIDIA, Microsoft, OpenAI, and a few others. And so one thing that I want to point out is that these tools have been used to help the research advance since GPT-4. So this is part of that recursive feedback loop. Even though the AI is not fully it's not fully autonomous recursive self-improvement, which I'll talk about in a second, it's still helping researchers, because even since GPT-4, people were brainstorming ideas about, okay, like, and what I mean is people inside these big labs with the original unfiltered, unneutered GPT-4. And so tools like the unfiltered, unneutered, unlobotomized GPT-4, Notebook LM, all these other different AI tools, guess what? Literally every researcher that I've talked to uses these tools to help in their own research. So even though it's not like completely fully autonomous, we're still getting that snowball effect. We're still getting compounding returns, because also every next generation of model is smarter and better at math, and can therefore help the researchers go even faster. And so you get this really good virtuous cycle going on. And this has been happening for at least the last year or two in most of the big labs. Before we move on real quick, I want to point you to my link tree. So this is just all of my links all in one place. I've got a bunch of YouTube channels. I'm on Spotify, so if you don't like YouTube, I'm on Spotify. I'm on Substack. All these videos get uploaded everywhere. I've also got a Patreon community with a $5 exclusive Discord. And then I've also got a learning community, which I need to update this, because it's not just a learning community. It's basically everything that I have to teach. I'm working on a new course called Unfork Your Life, which is basically everything that I've done wrong in my life, which is a lot, and figured out how to fix, is also another thing that I'm teaching. All right, moving on. Okay, so Farsi, and I know that Farsi is a language, so maybe this is a slightly problematic acronym, but it fits the bill. So Farsi, fully autonomous recursive self-improvement. The reason that I bring this up is because this is what a lot of people are talking about and thinking about, and have been thinking about it for a while. Now, what I want to argue is not just that, oh, this is a hypothetical thing that might happen and it might be dangerous. I'm not really concerned about how dangerous it is, because market forces. So this, first and foremost, there's an economic imperative, both at the corporate level and also the national level, to push for this. Because if humans become the bottleneck, right here, if humans are the primary bottleneck, then just remove humans from the process. That's what I mean by race condition, is that, okay, whatever is the fastest, most efficient, most cost-effective way to get to more and more intelligence, that is the path of least resistance for nations and corporations, whether you're competing within an American market or a European market, or on the world stage. So you get rid of all the bottlenecks, you overcome all the constraints, and you have a very, very powerful motivation to do this. It's an evolutionary pressure, so on and so forth. Now, what I will point out is that the species as a whole wins. If you step back and you say it's not about Microsoft or OpenAI or Tesla or America or China or Europe, the species as a whole wins from this race dynamic, unless of course we nuke ourselves out of existence. That's a different topic. Because this race condition means that everyone is incentivized to contribute to the pot. All the research that's being done, all the open source data, all the communication that's happening, and also a little bit of good-natured or less than good-natured competition spurs innovation. And that innovation will ultimately benefit literally every human, whether or not they're even participating in the race. Now, it could also harm every human. That is something that we will address a little bit at the end of the video. Now, another thing that I want to point out is that what we have found is that AI is intrinsically democratic. And what I mean by that is that AI research benefits from open source sharing. Research published by universities, research published by corporations, research published by nations. And when you look at, like, okay, another component. It's not just a decision to publish research. And in fact, there was a Reddit thread that Sam Altman replied to saying we might have been on the wrong side of history with regards to open source. So does that mean OpenAI will return to its roots and actually participate and be OpenAI again? I certainly hope so. And I think that China and DeepSeek has proven you just need to participate in good faith. Now, so there's that. Then there's synthetic data. So this actually came from several conversations that I've had with people, and we realize that all of human knowledge and all of human potential is being compressed into these models, and these models can reason from first principles, and these models can synthesize new data. Now, model collapse used to be a thing that you'd be worried about, but that seems to be a solved problem. Partially because, as I mentioned earlier, I think that the models are still trained on raw internet data, which are very high entropy and high noise. But so then you say, okay, 50% of the training data. And by the way, we know that GPT-4, I think it was like 13%. It was a non-trivial percentage of GPT-4 was trained on synthetic data. I think it's safe to say that the latest models are trained even more on synthetic data. There's probably an optimal ratio, like 50% raw wild internet data and 50% synthetic data. It might be different, and that could probably change over time as synthetic data becomes higher quality. Anyways, my point here, though, is that synthetic data is the way of the future, and proprietary data really isn't going to help anyone because you're going to spend millions, if not billions, on proprietary data when everyone could just liberate their data and then everyone wins. It's the win-win-win scenario by liberating all your data. Next is hardware democratization, which is after DeepSeek R1 came out, I had people messaging me saying, "Oh yeah, I'm running it on a 4090 or a 3090, with 16 gig of VRAM," and I'm like, "This is different." So it really seems like before too long, we're going to be running AGI on mobile devices, on home PCs. It's going to be running in your car, in your home, that sort of thing. Now, as I always point out, is those who have more compute still have an advantage. It means that they can run more of these instances in parallel. But you get the idea. All right, moving on. So as a quick recap, there is several virtuous cycles going on. So number one, it's all just math, and it's all a self-contained system now. Now, again, you will still benefit from inputting additional information from outside of that system, but that's where everyone is kind of converging on open source is really the best way forward. Next is dissolving constraints. So what I mean is data, compute, and algorithms are already open source. Energy is probably the biggest bottleneck. But if you've watched some of my other videos, I think that the energy problem will actually force us to solve decarbonization, because what's the best way to scale up energy is with cheap, abundant solar and nuclear fusion and those other things. It is also intrinsically democratic, and we are getting to the point of fully autonomous recursive self-improvement, although that is not strictly required just because the AI is a force multiplier for existing humans. So we will get to the point where humans are the biggest bottleneck, but it's not yet. And I suspect it'll probably be gut check about a year or two, maybe 3 years, before we can just take humans entirely out of the loop on all aspects of model research, including the safety part. I know that OpenAI has been working on automatic safety research, and I think it's pretty much a foregone conclusion that everyone is trying to automate every part of the pipeline, including adversarial testing, including red teaming, which I guess that's the same thing. Anyways, you get the idea. Now, I've talked in the past about terminal race condition, and so the long story short here is all factors combine to drive humanity towards achieving maximally efficient digital superintelligence. That is the terminal aspect. That's the terminus of the terminal race condition, which is singularity and we all ascend, more or less. So, as promised, I do want to talk about kind of the primary risk factors that I see from all of this happening, from all of these factors pulling together. So number one, nations and corporations are incentivized to make safe AI, because if you make an unsafe AI, the market will say, you know what, we're not gonna support you anymore. We're gonna use your competitor. And you look at how fast, for instance, Perplexity has adopted DeepSeek R1, and it's like, well, if we don't like that model, we won't use it. And so these models become completely interchangeable. They become almost completely fungible, which means that there are very quick market feedback mechanisms to reward models for being useful or valuable or safe. And there's also very quick feedback mechanisms to punish models and therefore the companies that produce them for being unsafe or unaligned. So I think that the market forces are actually solving this problem. I've talked to people who disagree with that, but I haven't seen any evidence to the contrary. I haven't seen any evidence that companies or nations are being incentivized to make evil AI or unsafe, unaligned AI. I see more evidence to the contrary. And so, you weigh it in one hand, that's how it seems like it's shaking out. Now, the biggest, or not the biggest, but the next risk factor is economic disruption. We're heading for a period of cognitive hyperabundance, and cognitive hyperabundance will absolutely reshape labor markets and the economy as we know it. How fast will that happen? Will it be painful? Will it cause consternation and riots? I don't think any of those are a foregone conclusion. I do think that in the long run, and I know that from interacting with a lot of you in the comments, that in the long run, yes, this will be good, but it's getting from here where we all still have office jobs and we need, we live paycheck to paycheck and that sort of thing, to after the fact, after society has integrated this into our economic landscape, then we'll be in good shape. But how long does that take and how painful is it? Those are really the two big questions. Next is wealth concentration. And what the bullet point says, failure to democratize AI ownership risks creating unprecedented social and economic inequality. The dystopian cyberpunk future. I've been talking about this for a few years now. This, I think, honestly, is the greatest long-term risk to human civilization, is that if it ends up in the hands of just a few, then we're going to be in bad shape. Now, the technology itself seems to be intrinsically democratic, but that does not mean that democratic institutions will adapt appropriately. We really need to invest in blockchain, collective ownership, decentralized ownership, and those sorts of things. And when I say collective ownership, I don't mean socialism as in the nation owns it. I mean you have decentralized autonomous organizations that own everything, and that everyone can participate in an arbitrary number of decentralized autonomous organizations. The next one is bioweapons. So basically, democratized AI greatly lowers the threshold of intelligence required to engineer bioweapons. Now, it's still not the easiest thing to do in the world. You still need a lab. You still need a lot of gear. You need people who know how to use that gear, and so on and so forth. But as AGI becomes more ubiquitous, as humanoid robots with IQs of 160 become more ubiquitous, again, the barrier of entry to making bioweapons is going to continue to decline. And that is honestly one of the biggest things. And the reason is because bioweapons require no energy once they're released. They require no further inputs or no further supervision. They continue evolving on their own, and they're completely borderless. So if you just look at the amount of energy and control required to input once released, as we saw this with COVID, whether or not it was a lab leak or a wet market leak, doesn't matter. It took on a life of its own once it escaped. Not even AGI or ASI can do that, because guess what? AGI or ASI still needs to live in a data center. It still has a reservoir that you can attack. Bioweapons have no such reservoir. They are truly fully autonomous and fully decentralized in a way that AGI and ASI never can be. And then finally, great power conflict. Right now, it's looking like it's going to come down to United States versus China. If you follow the news, Trump is doing a lot of stuff about, Greenland and tariffs and blah, 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 blah. All of that seems like Trump is preparing for a potential conflict by consolidating everything onshoring. So onshore strategy is national security policy at this point. Now, there are some articles out there saying like, oh, Trump just wants Greenland to, get minerals for his billionaire oligarch friends. I don't know whether or not that's true, but that still makes sense from a geopolitical strategy standpoint, which is, hey, we need to develop more mineral infrastructure so that we can, build this high-tech stuff. Well, it makes more sense if we control that. I am not endorsing invading Greenland or Canada. I'm just saying this is my analysis of why I think Trump is doing the things that he's doing and why it makes sense from a very cold, methodical geopolitical perspective. Again, not endorsing forcibly erasing or changing borders. I believe in the democratic and diplomatic process, and I think that we can find a win-win scenario between America and Canada and America and Greenland as things heat up around the world. So with all that being said, thanks for watching to the end. I hope you got a lot out of this video. Like, subscribe, etc., and check out my link tree. I offer a lot of stuff, not just on YouTube. All right, cheers, have a good one.